Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. So hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. So yeah guys, today's session is all about the continuation of FB growth algorithm. So it's a previous session we have introduced you what is FB growth algorithm, how it is differs from a priori algorithm, like those things we have learned. So yeah guys, before going for this session, as always, make sure you guys watched all the previous session videos so that you can have a better understanding of what we are telling. Okay, so today let us start working on this FB growth algorithm further. Okay, so what are the things that we are having today? First is, let us start with FB growth algorithm step by step explanation. Okay, so yeah, I hope like you guys already know about what is a priori algorithm. If you guys watched our previous video, you know about what is a priori algorithm, right? So we will be creating a simply the item list, right? In a priori algorithm we will be creating an item list. So how this FB growth algorithm is gonna work? Let's see. First is scan database. Scan the dataset to identify the frequent items and their counts, establishing a minimum support threshold. I hope like this is same, right? So we're gonna create a item set based on the minimum support range, and we will be eliminating all other things. Okay. Next, construct the FP tree. So that is, construct the FP tree by inserting the transaction, creating a nodes for frequent items and updating the accounts. Okay, simple thing. We're gonna create a tree-like structure where we're gonna have the items, like we will be having milk, bread, milk, and then biscuit, milk and butter, like that. We're gonna create a tree-like structure. Okay. Next, what we're gonna do next means we're gonna mine conditional patterns. That is, for frequent item set, construct a conditional FP tree and recursively mine frequent patterns. Okay, the thing is, we need to create an entire tree, and we need to create branches such that it will relate all other nodes. Okay, finally we're gonna generate association rule, extract frequent items from the FP tree and generate the association rules based on the confidence and uh, support thresholds. Okay, the thing is, it's simple, right? So what is meant by association rule? We guys already know about, right? So we will be having something called as a antecedent and then consequent. So based on the trees and the frequent items that we are having, we can create an association rule, right? So this is what I have bought, so that there is a high chance of buying this. Okay, so yeah, this is what the entire flow of what is FB growth algorithm, how it works step by step. Okay, so we need to scan the database based on the frequent items we are getting. We need to create a FB tree, and then we need to fix the confidence level. Then from the tree we will be arriving out what is the association rule. Okay, I think it's a more like very simple thing. Okay, so what the major thing it differs from a priori is, a priori do everything without creating a tree, but here it does with help of a FP tree. Okay, so yeah sir, over to you.
Hi guys, so if you have come to this session, so go watch all the session 5 to 10 times to reinforcement learning and have a long-term objective function, a career objective, what do you want to become? Okay, write in the comment section. Also subscribe to our channels and also press the bell icon and um, have patience, persistency, consistency, and perseverance, and long-term objective function for your career, what you want to become. And you have to go to meta level, do all the quizzes. There are more than 1,000 quizzes live, and also do the assignments, absorb the information, digest the information, and apply the information. So let's go to the FP growth algorithm step by step exploration. So step first is scan database, and so scan the dataset to identify frequent items. That is the first feature. And then the account, establishing a minimum support threshold. That is the first step for scan database. Okay, and then we have step 2, which is construct FP tree. So construct the FP tree by inserting transactions, creating nodes for frequent items, and updating their counts. So that is the second step. Then you have step 3, mine conditional patterns. For each frequent item, construct a conditional FP tree and recursively mine frequent patterns. And then we have step 4, generate association rules. So extract frequent item sets from the FE tree and generate association rules based on confidence and support threshold. So this is how it will work. So you have to understand these steps so that you will apply, understand first, and then what, why, and how. So you have to understand completely the algorithm conceptually, and then you will know, or you should know why, and then you should apply these concepts. Okay, so let's move to the other section.
Yeah, let's move guys. Okay, so this is what all about how to build the FP growth tree step by step. Okay, let's move on to the next thing. Okay, yeah, what is the FP growth algorithm advantage? Okay, FP growth algorithm's advantage over a priori. First, it is more effective, whereas a priori algorithm will create the candidate generation and pruning. You guys understand, right? We have created a tree. Based on the tree, we are just creating the association rule out of it instead of creating all the kind of permutation combination. That's the first thing. Next, fp growth algorithm is scalable. Okay, we can scale it to any large set, but performance degrades with larger data set, because like if we are having thousands of data set, thousands of items in a priori, we need to do the permutation combination of all thousands, whereas in fp growth we gonna create a tree like structure which will be easier for us to build the association role out of it. Then reduced memory usage, yeah, whenever we gonna have there is no permutation combination in fb growth, rather than we will be having a tree like structure. So whenever the repeating item comes, it just picks the node which is already present there. Okay, whereas in a priori algorithm it requires larger storage, because like it gonna create the candidate sets. Okay, so more likely a single point, since it's a tree like structure in fb growth, we will be connecting the node which is already exist. For example, there is three customers who gonna buy milk, biscuit, and then butter. One person buys milks and jam, and another person buy milk and something else like juice. Okay, everything comes to milk, right? Whereas in a priori we will be creating three candidates, but for the fb growth we gonna have only one thing called as milk, that will be a root node, and everything else will be our leaf node. So the size of storing the data will be very reduced in the fb growth when compared to the a priori. Okay, hope you guys have understand. So this is what the advantage of fb growth algorithm over a priori. Yes sir, over to you.
So advantages of FP growth over Apriori. So we have FP growth, and it is more efficient, guys, compared to Apriori, where candidate generation and pruning is required. Okay, and it is scalable. Apriori is performance degrades with large data set, and like here it is the advantage of FP growth over a priori. Okay, so you can see a priori advantages and sorry, fp growth advantages and a priori disadvantages. That's what I see. So reduce memory usage, and that helps like fp growth, but requires storage large candidate sets. So those are the differences, and this is how you need to understand for each algorithm. So what are the pros and cons, and what is the limitation, what are the limitations for different algorithms, why you're choosing for which model, what is the data. So you need.
Yeah guys, so we are just discussing about a priori. Okay, so yeah, so this is what everything, so advantages of a priori algorithm over fp growth. Okay, so yes sir, is there anything else that you want to discuss on this sir?
No, let's move to the other section.
Sure, sir. Yeah. So this is what all about a priori algorithm. So yeah. So this is the main reason why we are going from a priori to FP growth, because like FP growth we will be creating everything as a tree-like structure. So whenever we're creating a candidate set, right, we're gonna compress everything to a tree. So you guys can see when we have a three candidate set, it will be reduced to only 2 or 1 in the FP growth when compared to the a priori. So okay, so let's move on to the next slide. Okay, yeah, let's see what we are having. Yeah, we are moving on to the real world applications of FP growth. Retail, I hope like if you guys have attended our session, whatever the things that we have discussed in the association rule, that will be same here. Okay, retail, market basket analysis to identify the cross selling opportunities, because like what are the products we will be buying together with the product that we are having. Healthcare, discovering relationship between patient symptoms and uh, diagnosis, because like these are the symptoms that we are having, then this is like a medicine. Okay, like running nose, now also I am having, okay, running nose, and then cough, then you're gonna have a fever, take this kind of tablets. Like that we can create association rules, right? Then web analytics, identify websites, user behavior patterns and trends. Okay, okay, these are the websites they are just visiting. These are the pages that is giving more recommendations, like more visits, so that we need to recommend these kind of people to that, like those kind of web analytics that we can do by using FP growth. Okay, social network, we can analyze user interaction and identification influential users. Okay, like we all will be communicated and we will be connected through some social media kind of like LinkedIn. So using FP growth, it will create a tree-like structure to understand how we all are connecting. Only thing, right? We are all learning data science, so we'll be connected by using this root node called as data science. So using that, it tries to create a recommendation for us wherever we goes. In LinkedIn, it will create a post by saying it is related to data science, YouTube related to data science, Google related to data science. Like that, it will start creating a recommendation system by creating a FP growth tree. Okay, yeah, this is all the uh, real world application. And one more thing, guys, it is not restricted to here. There are n number of applications which are available. This is some things. Okay, as I always say, tell like this is four things I can show it in the PPT. Okay, there are n number of things. Okay, and n number of applications for this FP growth. Okay, yes sir, over to you.
So, real world applications of FP growth, we have application in retail, market basket analysis. You know, this is the very famous algorithm to identify cross-selling opportunities, and then healthcare, you can use it discovering relationship between patient symptoms and diagnosis. And analytics, you can identify websites, user behavior patterns and trends. And social networking, you can analyze user interaction and identify influential users, and do all kind of segmentation and stuff, so understanding them well. So this is how you can use it anywhere in healthcare, retail, web analytics, right? So web analytics, like every website needs this. Social media, all these places you can use it. And as per the like the objective, what is the objective of the project, so you can use and apply. So keep learning deeply. Let's move to the other section.
Yeah, sure sir, let's move on. Okay, yeah, conclusion and key takeaway. First is effective and scalability. This FP growth algorithm is more effective and scalable for association rule mining when compared to the a priori algorithm, because like each and every step we're gonna create a candidate set in a priori algorithm, whereas in FP growth algorithm we will be creating a tree-like structure and we will be deriving the association rules. Okay, then data compression. FP tree compression reduce the memory usage and improves the performance. True, right? Instead of creating all kind of permutation combination for the item set that we are having through the candidate set, in the FP growth algorithm, it's gonna create a tree-like structure where it's gonna have a compressed structure of all the permutation combination. Okay, that's the reason it leads to data compression. Real world impact. FP growth algorithm is widely used in various industries to extract the valuable insights over the data. Yeah, that's true, because like it's one of the recommendation system kind of thing, right? So yeah, guys, the main key takeaway for you is only thing, how a FB growth algorithm works will differ from the how it differs from the a priori algorithm. In a priori algorithm, we're gonna have an item set. We're gonna find all kind of permutation combination in the name of candidate set, and we're gonna fix a threshold that is support, and we need to find the what are the candidate sets that we are left out, and then we will be building the association rule. But Whereas here, we will be building the FP growth tree based on the item set that we are having, and we will be pruning the tree based on the support value greater than or less than. Then we will be creating the association rule out of it. That's it. Okay, hope you guys can able to understand. Yes sir, over to you.
So conclusion and key takeaways, guys: efficiency and scalability. That is there with FP growth is more efficient and scalable algorithm for association rule mining. Then you have data compression. It's FP is trees compression reduces memory usage and improves performance. And then it is real world impact is there. So widely used in various industries, extracting valuable insights from the data. So these are very important key takeaways in conclusion. See you in the other session.